All right, here we go. In the figure, the coordinates of P are those. They want you to know what they are. They want to know what they are. Well, this is a unit circle problem, right? Whoops. Hello. All right, here we go. In the figure, the coordinates of P are those. I'm hearing myself. So remember the unit circle? Remember how with the unit circle we had, this is 5 pi over 6, which means this over here is pi over 6. Pi over 6 is 30 degrees. And so this angle, this triangle right here, that's a 30, 60, 90 triangle, right?
Oh, okay. Yeah.
And so the coordinates, if you remember 30, 60, 90, you remember the special right triangles? If this is, I can't really read that. Is that a 5?
5, yeah.
Okay, so then the smallest side would be half of 5, right?
Yeah.
And the middle size would be that times the square root of 3. Got that?
Yeah.
So what are the coordinates? Well, it's a negative going left, right?
Yeah.
So the x coordinate is negative 5 root 3 over 2, and the y coordinate is positive 5 halves. Got it?
Yeah.
All right. If DB is the diameter of a circle, C, and CAB is 25 degrees, then ADC is what? So they want they want this one right here. And it says that it's a diameter. Well, since it's a diameter, remember that one property in geometry where a diameter, where if you inscribe an angle in a circle, then this angle is this. Let's see. What am I trying to say? Let me think about this for a second. Hold on. What property am I trying to think of? Okay, hold on. DB is a diameter and CAB is 25. CAB is 25. Then that is what? Okay. Oh, my bad. I got it. So this right here, this angle is a right angle right here. Because from here to here is 180 degrees.
Yeah.
And an inscribed angle is half of it.
Okay.
So that angle is 90. That big angle is 90 degrees, which means this angle right here is what? 65? Right?
Okay.
You got how I did that?
Wait, how did you get to 65 again?
Because this angle here is 90.
Oh, okay.
This angle has to be 90 right here because it's inscribed in a semicircle. Remember from geometry, if the arc length is 180, then the angle that's, I can't remember what you call it, cut by that is half of that. So that's a 90 degree. That's a 90 degree angle. And since this is 25 here, this has to be 65 here. Okay, so D, but they don't want that angle. They want this angle here, ADC. So what else can we do? Oh, I know what else we can do. These two sides right here are both radii, so they're equal to each other, right?
Okay. Yeah.
And since that's an isosceles triangle, what do you know about these two angles here and here?
They have to be equal?
Yeah, they have to be equal as well. So these two are equal as well, so that means the answer is 65.
Okay.
Okay, so there were a couple different properties that we were using from geometry, from algebra 2 trig. Lots of good review there for that one. Good. Any questions on that, or you got it?
I'm good.
Good.
Yeah.
All right. Astronauts at point A are m miles above the surface of the Earth. They make a rough measurement of OAH, the angle between the direction to the horizontal and the center of the Earth. Oh man, this is tricky. Astronauts are point A, are at point A. Okay, here's their that's where the astronauts are, which is m miles above the Earth. So this is m. This distance is m, the surface of the Earth. They make a rough measurement of OAH, the angle between the direction of the horizon and the center of the Earth. So this is the tricky part. What are they talking about? The horizon. So I think that's this. And the center of the Earth, which is going to be just straight down to here, I believe, if I'm reading that correctly. If the OA, a measure of OAH is 45, so this is a 45-degree angle. What is the radius of the Earth? So they want to know R right here.
Okay.
Got it? So they're trying to find out what R is, the radius of the Earth. Well, notice that R is here and here, right? Just like on that last one.
Yeah.
Right? So let's come up with an equation for this. So I know that this is a, if this is a, this is going to be a right angle because it's a tangent. So
Okay.
this is a 45, 45, 90. Wait, that doesn't seem right to me. But I think that's true. So that if that's 45, then that means that this is like the last problem. This is a 45, 45, 90. So those are equal to each other. So we know that this is R as well. So we know that the equation is that R squared plus R squared equals M plus R squared. Oops, M plus R quantity squared. See how I'm using Pythagorean in there?
Yeah.
So 2R squared equals, I'm going to distribute this now, or I'm going to FOIL that out. M squared plus, no, let's not do that, equals M plus R squared. Now let's take the square root of both sides. So the square root of 2 times R equals M plus R. So I'm trying to solve for R. So I'm going to subtract R from both sides. So R squared root of 2 minus R equals M. I'm going to factor R out. Square root of 2 minus 1 equals M. So R equals M over root 2 minus 1.
Okay.
I know I did that kind of quick. Go back and watch the video if you didn't follow it. But I believe that is the correct answer. All right, one factor of the expression, blah, 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 is, well, one factor is going to be AB squared, right? But that's not one of the choices they're giving you. So let's factor out AB squared. When I factor out AB squared, here I'm left with B, and here I'm left with A squared, just A squared. So what's the factor? Well, this is one of the factors, but this is the other factor. B minus A squared.
Oh.
Got it?
Oh.
See how I did that?
I do that, yeah.
The trick to that question is the obvious factor was AB squared, but that's not the one they wanted you to answer. That wasn't one of the options. Got it?
Yeah.
The period of that, remember how period is just 2 pi over B? Do you remember that?
2 pi over B.
And
Yeah.
that's B. So your period is just 2 pi over 3.
Oh. Okay.
Good?
Yeah.
All right. A lot of that stuff was new for you because have you learned trig yet, Sahil?
No.
Yeah, so that might have been a little bit over your head, and that's okay. Don't be ashamed. That's some new stuff. But hopefully it piques your interest to learn trigonometry because it's pretty awesome. Trig is pretty fun. All right. All good, guys?
Yep.
Yeah.
All right. I'll see you tomorrow.
Okay.